Find the maximum value of this function. We have the difference of two squares in the top and an x in the bottom. If we try to analyze its monotonicity, it doesn't really help us because the top is increasing and the bottom is also increasing. But we do see that the coefficients of the polynomials in the numerators are symmetrical, which means we should try to divide it by x squared. So f of x, let's split it into two fractions. X is essentially the same thing as the square root of x squared. So now let's make the square root cover the whole fraction and divide x squared into the polynomial. And this is what we get. Because we see x squared plus 1 over x squared repeating, we can represent it with one variable. Let t represent x squared plus 1 over x squared. And we also have to state the range for the values of t. Because x squared is, in this case, our variable, x squared must be positive, which means that the function of x squared, in this case t, has a minimum value of 2 times 1 over 1. In this case, a and b are both 1. This means that t is greater or equal to 2. So now let's rewrite f of x using t. Here we see the difference of two square roots, and we can't really analyze further because they both have a monotonicity of increasing, and we can't really determine anything from that. But we can use what we know about rationalizing the denominator. We can rewrite the whole expression like this. The top would become 1, and the bottom would be square root of t plus 1 plus square root of t. And we know that the denominator has a monotonicity of increasing. But since it's in the denominator, we know that this whole thing, f of x, is decreasing, which means that we can find the maximum value of f of x when t is at its minimum. We know that t has a minimum of 2. So let's substitute in t is equal to 2. F of x can also be rewritten like this, so let's just directly use this form of f of x. F of x will have a maximum value of square root of 3 minus square root of 2.